If you really do have any questions about this, you're not understanding something, I really need you to speak up because this is the last day we're gonna do volume. But you'll have about 3 or 4 or 5 questions at least on an exam about volume. All right, let's go. Okay, so just a quick review from last class. And if you have, well, you do have a formula chart. I sent it to you in Messenger. I really would prefer you to download that on your iPad so that you can see what I'm talking about instead of just listening to me tell you what the formulas are. So making sure you know where the formula looks like and where it is on the formula chart will benefit you. So last class, we talked about cylinders. And then, oh, that is not a cylinder. And then somebody was making fun. What is the world? That's not me, guys. My drawing is better. Something is going on with my tablet. Somebody was talking about my drawings yesterday, so I got to do better today.
Who was it?
One of the art students. They're like, "That's not how you draw a cylinder." I was like, "Don't be making fun of me."
I should have put something on the Facebook.
So this is the best it's gonna get. So last class we talked about what we need from the cylinder is the radius and the height. And the formula was V equals capital B times H. And we knew that capital B stands for, does anyone remember?
Area of the base.
Area of the base, yes. You get a fake treat. There you go. Area of the base. And since my base is a circle, there's my base, it's a circle, I have to look to figure out what the area, what in the world is going on? Area of a circle is, which is pi r squared. So instead of capital B, I write pi r squared, multiply that by h. Okay, so that is a quick review from last class that hopefully everyone feels confident with. So let's go ahead and move on to what we're learning today. So we're learning about the volume of a cone. Go ahead and draw a cone on that paper and the formula for a cone. My writing instrument is acting up a little bit, so my handwriting might not be the best today. Alrighty, so the formula for a cone is very similar to the formula of a cylinder. What's the difference? The 1/3, that 1/3. And that's because a cone is a third of a cylinder. So like if I had a demonstration for you, I would find a cylinder with the same height and radius as a cone with the same height and radius, and I would get some water and pour it in the cone. And I would be able to fill that cone up 3 times and pour it into the cylinder, and it would be full in the cylinder because a cone is a third of a cylinder. So that's why it's 1/3 times capital B times H. So again, capital B is not just the radius. Capital B is the area of the base. What shape is the base on a cone? A circle. So 1/3 capital B times H. That capital B is going to break down into the area of a circle, then times height. Okay, so I like doing this illustration to remind myself, well, the base is a circle. Capital B stands for the area of the base. Capital B stands for the area of the base. And since my base is a circle, I have to write down the area of a circle. And the area of a circle is pi r squared. Again, this is not something that I just know at the top of my head. It's something on your formula chart. So the formula will break down into 1/3 pi r squared times height. Some of you might be wondering, why do you keep writing this first formula then, the capital B times H? Because this is the one that's on your formula chart. Why do they not just put this one? I have no clue, okay? But this one right here is the one on your formula chart, and you have to know that it breaks down into the pi r squared part. So this is the part that you need to understand. Capital B breaks down into this. If you can make this connection, then you're good. If you still don't understand the connection, I need you to speak up about it. So let's look at some more. So capital B, we talked about, is the area of the base. The shape of the base is a circle. So capital B turns into pi r squared because the area of a circle is pi r squared. Okay, if you understand that point, if you understand why capital B turns into pi r squared, can I get a virtual thumbs up and then a thumbs up in the classroom if we understand that? Cool. Good. All right. So let's look at, I think the next one's an example. Let's see. Oh, that's just showing the formula chart again. Okay, and this is just breaking it down. So if you don't have this in your journal, I would write this down, make sure you understand it, and then we're going to look at an example. Okay, so here is it with actual numbers. So the height is from the point of a cone to the circle part. So this 8 would represent the height. The radius, this 5 would represent the radius because on my base, on my circle, that 5 is halfway across the circle. So that 5 would represent the radius. What if that line went all the way across? Perfect. So if this line went all the way across, that would actually represent the diameter, and I would have to divide that by 2 to get my radius. Okay, so here I have V equals 1/3 pi 5 squared times 8. Just like last class, have a good example in your journal. So at least have one good example. So if you haven't drawn this, I would have one good example. And then everybody with me is going to put this in Desmos because you need to know how to use it and put it in the calculator, especially now that we have a fraction we have to do. So on Desmos, we're going to put this in, okay? And I want everyone to do it with me because you have to know how to do this. You have to know how to do this. Is everyone on Desmos? All righty. All right, so I'm going to bring my keyboard up. So the first part is the 1/3, right? So parenthesis, 1 divided by 3. Automatically, it should put that in a fraction. Everyone has that? Now I'm going to click to the side now of the fraction so that I'm not on the bottom anymore. So I'm going to put my finger on the side, and then I'm going to write pi parenthesis. Well, the radius was 5, right? 5 squared. The square button is at a to the power of 2 squared close the parenthesis. And then I like to put parentheses, but you don't have to with the 8. And you should get 209.4. Yeah? Okay. And the more you use Desmos, the more comfortable you'll get with it. Okay. So the volume of this cone in particular would be 209.4 inches cubed. All right, I'm done with the cone. Any questions? Everyone's pretty straightforward. Today's gonna be like 10 minutes. So all right, I think we have an example. Let's see. Good morning. Yes, we have an example. All right, so either you can do this on paper or you can do this on the Drawlet, but I really want everyone to try it. This 2 on the circle is the what? The diameter. So what's the radius? 1. So I gotta split that in half. So the radius is 1. And the height is what? 2. Okay. So go ahead and figure it out and we'll check our answers together. I'll give you 2 minutes. And what I want to see is I know a lot of people just say, well, miss, I just put it in the calculator. I want to see the work. I want to see what formula you're using and breaking it down. Okay, I don't want to just hear, oh, I did the calculator. All right, anyone bold enough to share what they got?
I got 2 or 2.09.
That's exactly what I got. Good? Good? Good. 2.09. 1/3 times pi times 1 squared times 2. When you put it into Desmos, you should have got 2.09. If not, if you didn't get that and you figured out your error, please share so that we can like talk about the mistakes that we make. Okay. So we are done with the cone and we're moving on to a sphere. Okay. Good job, everybody. Good job. Ooh. Sorry, I meant to hide the names. My bad. 1/3. So if you did not get that, remember also put it into Desmos all at once. Do not do the 1/3, then times the pi. Oh, let me see what that equals. Oh, then times the radius squared. No, just put it all in at once. So 1/3 times the pi times the radius squared times the height. And that will give you your answer, 32.09. Don't try to split it up and do it and just put it all in at once. All right. Here's a sphere. Go ahead and draw a beautiful sphere on your paper. A sphere is what? A circle, a 3D version of a circle. Okay, so a beach ball, a basketball. Those are some examples of a sphere. The formula for sphere is volume equals 4/3 pi r cubed. V equals 4/3 pi r cubed. Not squared, cubed. V equals 4/3 pi r cubed. What's the main reason people get this wrong? Is because they accidentally square it, which I've done that before. Okay, so that's why it's always important, write down the formula first and then fill in your numbers. So 4/3 pi r cubed. So the only thing you need here is the radius of the sphere. Okay, so let's say I have this radius of 2. So it's from the center of the sphere to the outer edge. The radius is 2. I'm going to put 2 in for radius. So volume equals 4/3 pi 2 cubed. And we're all going to put that in Desmos together because you need to know how to do the cube part. So everyone go to Desmos. So I'm going to talk you through it. So first we want to do the 4/3 part. And I like to put things in parentheses. That's just my preference, but you technically don't need to put the 4/3 in parentheses. So parentheses 4 divided by 3. And then I touch to the side of the fraction outside the other parenthesis. Pi. And then in parentheses, I like to put 2 is the radius, 2. And to do cubed, you see where it says a to the power of b? You'll press that and it'll bring up the exponent and you'll put the 3 there. And then it'll give you your answer. So everyone should get 33.5. If you didn't get that, just let me know. I'm here to help. Hey, Farah. 33.5.
How do you cube it again?
So you press the A to the power of B button. So let me go back. So you press, so I put the 2, and then I press A to the power of B, and then you should notice it brings up the little cursor to make an exponent, and you press 3. So there's your cubed. Alrighty. So what was that, 33.5? All right, so volume equals 33.5. All right, inches cubed. All right, so let's see, I think we have an example, and then we're done. Okay, so find the volume of this sphere. Find the volume of this sphere. And you need to have your formula chart so you know what the volume formula is.
Miss Person.
Uh-huh.
The circle has to be like perfect.
Does it have to be what, baby?
Perfect. Because
No, like you're drawing?
yeah.
No, I cannot make a perfect circle. As long as you understand that 4 here represents the radius, then we're good.
My hair.
Oh, was it your allergies?
Yes, and because I don't have my glasses.
Oh,
But they're gonna get fixed today.
did y'all get 268.08?
Yes.
Good. If you did not get 268, let me know. But in the Desmos, you should have just done 4/3 pi 4 cubed. Good. We're done. That was fast. Job. Okay, so I need it. If you didn't get that, let me know because we're about to do the assignment now.